And the theorem is the line drawn in the line segment joining the midpoints of two sides of a triangle. Yes, Tejas, you can keep yourself on unmute. Is parallel
midpoint theorem, right?
Yes, it is midpoint theorem. Okay. Okay, so the theorem says that, let's try understanding. The theorem says that the line segment joining the midpoint of two sides of a triangle. Okay, if we are having a triangle ABC, then the line segment joining the midpoint of two sides. Suppose side AB is having its midpoint. Okay, B, I am writing it. And side AC is also having midpoint. Let's say E. Okay, I am writing it. Suppose we know that this D is the midpoint of AB and we know that E is the midpoint of AC. Then if we will join this DE, that this DE will be parallel to the third side. Okay, that's what the theorem says, that the line segment joining the midpoints of two sides of a triangle is parallel to the third side. If you will take, suppose you are having a triangle, okay, triangle PQR. If you will take the midpoint of QR, okay, let's say M. If you will take the midpoint of PR, let's say N. And if you will join them, it will be parallel to the third side, which is the third side PQ. Am I making sense to all of you?
Yes, ma'am.
Rest of the student? Okay, so if you will join in a triangle, if you will join the midpoint of two sides, automatically that line segment will be parallel to the third side. Okay, that's what we have to prove over here. And the name of this theorem is midpoint theorem. Let's prove it.
Can I note the midpoint theorem?
Yeah, sure. Okay, the name of this theorem is midpoint theorem. Midpoint theorem. Okay, it is very clear from the theorem itself, from the statement itself, that if you are joining the midpoint of two sides of a triangle, okay, the line which you will be getting while joining it, this line will be parallel to the third side of the triangle. Okay, who joined just now? Farhan, you joined?
Yes, ma'am.
Okay, so I was explaining midpoint theorem. Okay, already the statement I was explaining, that what the statement says, if you are having a triangle, okay, and suppose D is the midpoint of side AB and E is the midpoint of side AC, and if you will join these two midpoints, you will be getting a line which will be parallel to the third side, that is BC of a triangle. Okay, line joining the midpoint of triangle will be parallel to the third side. Okay, let's prove it. Yes, have you noted, Tejas?
Yes,
And
ma'am.
yeah, everyone? Let's prove it. So I am drawing the triangle again over here. At first here we'll be doing one construction to prove it. Okay, just let's discuss what we'll be doing over here. Okay, then I'll be writing everything. Let it be. Just a second. I'm explaining first, okay? If needed, I'll be explaining again and then we'll be writing everything, okay? So just focus. Just just keep your pencil and pen and paper copy aside for a while and focus over here. Concentrate, because you need to understand, so that once I'll be done with the explanation, you will be able to do by yourself. Okay? So listen to me. What we will do, we are having a triangle. Okay? And we have to prove that when we are joining the midpoint, okay, midpoint of the side AB, suppose D is there, and midpoint of AC, again E is there. If we are joining this two midpoint, this line D is parallel to BC. That is the first thing we have to prove. However, this D is also half of the length of BC. Okay, this also we will end up proving over here. Okay, this line DE is parallel to BC. The purpose is to prove DE is parallel to BC, and also we will find that, like, we will end up getting that DE is equals to half of BC. Okay, so for that, at first we need to do one construction. Okay, what we will do, I'm going to extend this DE. Okay, we will extend this DE, suppose till M. Okay, and we are doing this construction in such a way, we are doing in such a way that so that DE is equals to EM. Okay, extending the side DE till M, such that DE and EM we are maintaining same. And now what we are doing now, joining this E with M. Okay, just a second. Just a second. Joining C with M. Okay, we are doing the construction, we are extending this DE till M such that DE and EM both are equal. That way we are doing the construction. Okay, and then we are joining this M point with this C like this. Now can we prove that this triangle and this triangle are congruent? I mean this triangle and this triangle, can we prove these two are congruent with each other? Can we think
Yes,
about it?
ma'am.
Yes, rest of the student. How we'll be proving it? So here, can you see a vertically opposite angle? Can you see everyone a vertically opposite angle? Okay, angle
Yes, ma'am.
angle A. This was C. No, this was E. Okay, angle AED is equals to angle CEM, vertically opposite angle. Okay, this is just the explanation part. We'll be writing everything properly. Now, apart from that, now only I was telling you that we have done the construction in such a way that so that DE and EM are same. So of course, DE side and EM side we can use over here. And what else? So since E is the midpoint, AE and EC will be equal, right?
Yes, ma'am.
In the original triangle, if E is the midpoint, this one and this one will be same length. Yes or no?
Yes, ma'am.
Okay, everyone getting it?
Yes, ma'am.
AE and EC will be equal, and on the basis of this three, we can see that this triangle, that triangle are congruent. Let me write the name properly. The name will be AED. Let me check. If I am writing AED over here, will be congruent with E is equals to E over there. Okay, DE is equals to EM over there. Okay, so CEM. AE is equals to EC. Yeah. These two triangles we have proved very, like, it was very simple for us to prove vertically opposite angle, construction, and one of the midpoint. These three we have used the data and we proved that this triangle, that triangle are congruent with each other. Okay, Now, once we are done with proving the congruency of this two triangle by CPCT, okay, by CPCT, can we say that side AD over here is equals to side CM over there? Can we say that?
Sure, ma'am, it is.
Yes, everyone, can we say that? Can we say AD side AD over here, okay, is equals to CM over there by CPCT? Just now we have proved the congruency. This AD and this CM, these two are same. We can say that, right?
Yes, ma'am.
Okay. If we can say that these two sides are equal in length, what else we can say? Just a second. So if we can say these two are just a moment. Yeah. If we can say these two are same length, now let's focus on this one, this quadrilateral. Okay. We are saying that we know already that we know that AD is equals to BD, okay, because D is the midpoint, and here we have written by CPCT AD is equals to CM, so we can say that CM and BD both are same. Yes or no? Can you see this two rectangular box? AD is equals to BD. Why? Because D is the midpoint and AD is equals to CM. These two yellow color lines are same. Then we came to the conclusion that CM and BD are equal in length. Yes or no?
Yes, ma'am.
Everyone getting it? I'll summarize,
Yes,
don't
ma'am.
worry. Okay. So CM and BD both are equal in length. And what else? So just a second. These two opposite sides are equal, and if we will take DE and EM both are same. Yeah, actually wait, something else we must get so that we can say this BDCM is a parallelogram. Okay, let me check what else we are getting. Angle A over here is equals to angle C over there. Just a moment now. Angle A over there is equals to angle C over there. Yeah. If angle A over there is equals to angle C over here, can we say that CM is parallel to BD or AB? Can we say that
No.
CM is parallel to AB? Yes or no?
Yes, ma'am.
Yes, everyone, rest of the student. By CPCT, we are getting angle A over here is equals to angle C over there. Okay, just now the two triangle we have proved congruent. From there, we can see by CPCT, angle A and angle C are equal. Yes or no?
Yes, ma'am.
Okay, if angle A and angle C are same, then it looks like a two just random line we are having AB and CM, and there is a transversal where alternate interior angle are equal. So of course this two line will be parallel with each other. Yes or no?
Yes,
Yes
ma'am.
or
Yes,
no?
ma'am.
Okay, I am writing over here that angle DAE is equals to angle MCE. Okay, by CPCT. Therefore, AB must be parallel to CM. Okay. Therefore, AB must be parallel to CM. And that day we were discussing, if you will cut the parallel line, still it will be parallel. If you will extend the parallel line, still it will be parallel. So from here I am going to say, since AB is parallel to CM, BD will also be parallel to CM. Yes or no?
Yes, ma'am.
Since AB is parallel to CM, BD will also be parallel to CM, because BD is just a part of AB. Yes or no?
Yes, ma'am.
Okay. Since AB is parallel to CM, therefore we can say that, which implies that BD is also parallel to CM. Now focus. Okay, this AD is equals to BD and BD is parallel to CM. Okay, I mean this one and this one, these two circles. Okay, these two circles. Okay, CM is equals to BD. I'm drawing the triangle over here. First, you need to understand. I'll be writing everything. Okay, you can note it down, but you need to understand. Okay, I have extended it till here and have joined. The name was ABC. Here it was DE. Okay, and here it was CM. Yeah, it was CM. Okay, so BD is parallel to CM. Now we are saying that this BD is parallel to CM, and we are saying that CM is equals to BD. Okay, these two sides are equal also, parallel also. So that is the property of parallelogram. No other quadrilateral can behave in such a way that opposite sides are equal also, parallel also. So we are not showing both the opposite side, no worries. Even one of the opposite side we are saying no, that it is parallel also and equal also. If I will say only parallel, then also there can be confusion. If I will say only equal, then also there can be confusion. But I am saying it, this BD and CM are parallel also and equal also. So that can be parallelogram only. Am I making sense?
Yes, ma'am.
Yes, ma'am.
Okay, therefore BDCM is a parallelogram. And if it is a parallelogram, then we are done. What we wanted to prove here, we wanted to show that DE is parallel to BC, and we are done. Okay, if it is a parallelogram, then DM must be parallel to BC, which implies that DE also parallel to BC. Yes or no?
Yes, ma'am.
Which one is a parallelogram? We prove that this is a parallelogram. If this is a parallelogram, this DM, okay, here we were having M, DM and CB is a parallel, of course, because we have done the proof that it is a parallelogram. Okay, so DM and CB is parallel. From there we are saying DE and BC are parallel, and midpoint theorem proved. Yes or no? Getting it?
Yes, ma'am.
Yes,
Okay,
ma'am.
I am summarizing everything over here. That what you were having. Okay, this is the second time I am summarizing it. Then third time we'll be writing it. Okay, so again focus. We were having a triangle. The name of the triangle is ABC. Okay, the midpoint of AB, we know D is the midpoint of AB. We know that given in the theorem. We know that E is the midpoint of AC. We know that given in the theorem. Now joining these two midpoints, okay, the line segment DE is parallel to the third side. That's what we have to prove. What we have to prove, you don't have to copy now. Okay, we have to prove that DE is parallel to BC. We are doing one construction at first. Okay, extending DE till any name you can give M. Okay, and joining C and M like this. Okay, now we are focusing on triangle ADE and triangle CME. Okay, this triangle and that triangle. Which two triangle? I am talking about this two triangle. Quickly you have to prove congruency. Okay, it was very simple. Vertically opposite angle. Okay, this side and this side were already same because of the midpoint. And the construction we have done in such a way, I forgot to write over here that we have done the construction in such a way so that DE and CM are same. Okay, this DE and CM we have maintained the same distance. So of course by angle, angle side, these two are congruent. Okay, if these two are congruent, then now our focus is to say that this, now our focus is on this one. We are keeping this congruency aside for a while. Okay, after proving it, now we will focus to prove this one as a parallelogram. By doing anything, we want to prove this yellow color quadrilateral as a parallelogram. Okay, so that we can say that DE is parallel to BC. Okay, so how we are saying it's a parallelogram? We are saying that angle A over there, okay, angle A over here is equals to angle C over here. Okay, it will only be possible when angle A over here and angle C over here will be only, these two are same. Okay, by CPCT these two are same and it looks like a alternate interior angle. So from here we are saying that AB is parallel to CM. From here we are saying that AB is parallel to CM, and hence the yellow color we wanted to show as a parallelogram, no? So we are able to say that yeah, BD is parallel to CM also. Okay. Now these two are equal also. Why? Because AD is equals to BD, because D is a midpoint. AD, BD are equal because D is the midpoint. Okay. And by CPCT we have also got, that this AD is equals to CM. So AD is equals to BD, AD is equals to CM. We are doing the comparison. Just a second. Yeah, AD is equals to CM. From here we are saying that BD and CM, this BD and CM are equal also. Oh yeah, these two are parallel also and equal also. That means that it must be a parallelogram. Okay, no other quadrilateral follows such property. Okay, in trapezium also one of the pair of sides are just parallel. Okay, not equal. In isosceles trapezium, the legs are equal. Okay, so parallelogram, we can say this is the property of parallelogram only, that the opposite sides are parallel also and equal also. Have we shown both the opposite side? We don't even have to show both the opposite side. If one of the opposite side you are saying it is parallel also, equal also, that is only the property of parallelogram. From here we are declaring that BDCM is a parallelogram and hence DE and BC are parallel. Got it? Everyone got it?
Yes, ma'am.
Tejas, you got it. The rest of the student.
Ma'am, can you explain the theorem?
Yeah, theorem also.
Yeah.
I am saying that theorem says that it is given in the theorem that if you are having a triangle, okay, ABC, suppose D is the midpoint, okay, given there, it is given over here that D is the midpoint of AB. And it is also given over here that E is the midpoint of AC. Okay, then we have to show that when we will join these two midpoints, the line segment will be getting DE. It is parallel to BC. That's what we have to show. That line segment obtained by joining the midpoint of two sides of a triangle are parallel to third side. So if you know that there is a midpoint of one of the side and there is a midpoint of another side and you are joining the midpoints and getting a line segment, that means that line segment will be parallel to the third side. That's what we have to prove. Okay, to prove it, we are doing a construction. We are extending this side DE till M and we are joining this C with M. Okay, we are doing the construction in this triangle that DE is equals to EM we are maintaining, okay, and also joining C and M. Okay, after that we are trying to prove this triangle and this triangle congruent. Okay, once we are proving this two triangle congruent, then we are focusing on proving this one as a parallelogram. कैसे भी करके अगर इसे हम पैरालेलोग्राम प्रूव कर दें तो हम डायरेक्टली बोल पाएंगे कि हाँ डीई किसके पैरेलल है, बीसी के, जो कि हमें प्रूव करना है. क्यों पैरेललोग्राम ले रहे हैं? क्योंकि डीई पैरेलल टू बीसी हम प्रूव करना चाहते हैं. ओके, तो पहले कन्ग्रुएंसी फिर क्यों हमने प्रूव कर दिया? क्योंकि सबसे पहले ही हम इसे पैरेललोग्राम प्रूव करना चाहते हैं, बट हम पैरेललोग्राम प्रूफ नहीं कर पा रहे. ओके, at first only we want to prove this purple color quadrilateral as a parallelogram, but let me tell you it will not be possible. So we are taking the help of congruency. At first we are proving this two pink color triangle. Yes, Azia, you want to say anything? Yes.
Yes, ma'am.
Yes, tell me. Yes, please tell me. Yes, Sazia, do you want to say anything? I can't hear you, Sazia. Anyone who can hear her, can you write it
She's
in the
saying
chat?
no, ma'am.
Okay, you don't want to say anything. Okay. So at first we are proving this two pink color triangle congruent, and then we are focusing on proving this purple one as a parallelogram. Let's write the steps. Okay, let's write the steps properly, then it will definitely make sense to you. Okay, so I'm writing. Now you can copy with me. Okay, proof. I'm drawing the figure. Given D is the midpoint of AB, then we can write AD is equals to BD. Okay, and E is the midpoint of AC. Then we can write A is equals to AC. Okay. Two equations we have created. Let's see, we'll be using it also. Now we have to show that DE is parallel to BC. Okay. Now let's do the construction first. Construction we are doing extending DE such that DE is equals to EM. Okay, and
EM, right?
yes, EM also joining M and C like this. Okay, this much construction we have done. Now we will focus on proving the triangle. Now in triangle ADE and triangle CME. Okay, ADE and CME. We will try proving this two triangle congruent. Let's do it. I'm again drawing the same figure over here so that you will not get confused with the triangles and me. Okay, so here we will say that angle AED is equals to angle CEM, vertically opposite angle. Write it properly. Then we will say that AE is equals to EC, given we have written also in equation 2. From 2 also you can write. Okay, and what else? So now only we have done EM. Okay, construction. Then by side angle side, is it congruent?
Yes, ma'am. Oh,
Okay,
yes, yes.
let me check. This is angle. Yeah, side angle side teachers. Can you see it? Yes, everyone. Is it side angle side? Is it side angle side? Okay, these two triangles are congruent by side angle side. Okay. Now we will focus on proving this BDCM as parallelogram. Okay, it must be there in your mind. Then otherwise you will struggle that what exactly we are doing. You will end up just memorizing all the steps. So just keep in mind that first we are proving this two triangle congruent. Why? Because that will help us proving BDCM as a parallelogram. Okay. So let's prove that BDCM is a parallelogram. I am going to say that we know that AD is equals to BM. Okay. From 1 we know that. From equation number 1 we know that AD is equals to BD. Okay. Because D is the midpoint. D is the midpoint. Of course these two are same. Okay. And now only we are from this congruency we can see that. From this congruency we can see that AD is equals to Cm. Let's write it.
Can you do this?
Uh, what you say, Sasya? Scroll up or what?
Yes, ma'am.
Okay, do it first. Once you are done, please let me know.
Done.
Okay, let's do. By CPCT, I have written that but AD is equals to CM by CPCT. Therefore, from this two we can write that BD is equals to CM. Okay, equation number 3. Now we are going to say that AB is parallel to CM. Okay, I'm going to write that AB is parallel to CM. Why? Because this angle A over here is equals to angle C over there, again by CPCT. Okay, so angle DAE is equals to angle MCE. Angle DAE is equals to angle MCE. MCE? Yeah, MCE. Vertically, wait, alternate interior angle. Pair of alternate interior angle. Okay, it implies that BD is parallel to CM. Check it in your paper. Okay, number 4. From 3 and 4, we can say that it's a parallelogram. Okay, from 3 and 4, it's enough to say that BDCM is a parallelogram. Therefore, of course, BD is parallel to, DE. Let me make the figure over here. Then only it will make sense to you as well. Tell me if I have to scroll up, down, whatever. Okay. So A, B, C. Here we are having DE. We have extended till M. We have joined this with, okay, BDCM is a parallelogram. Therefore, this DM must be parallel with BC. Okay, which implies that DE is parallel to BC. Okay, hence proved. That's midpoint theorem. What you have to keep in mind, construction. Okay, and which two triangle you will be starting with. Okay, first construction, you have to keep in mind that you are extending the midpoint, that line segment, till whatever be the point, and you are joining it with C. Okay, and then this two triangle. Okay, you will be proving congruent ADE and CME. That will help you proving that BGCM is a parallelogram, and then we are done almost. Got it?
Yes, ma'am.
From here we are getting one more data. Okay, you can keep it in note here. This DM is equals to BC also. Okay, as
So their half is also equal.
as yes, DBCM, it's a parallelogram, so it must be equal, right?
Yes, ma'am.
And from here we are saying DM is nothing but DE plus DE, or half of DE, whatever you are writing. Okay, that means half of, wait, 2 times DE is equals to BC, right? That means DE is half of BC. Is it making sense to all of you that DM and BC are equal with each other? DM means DE plus EM, but DE and EM both are equal. DE plus EM, but DE and EM both are equal. That's why I am writing DE plus D. Please don't get confused. DE and EM both are equal. That's why I am writing DM as a DE plus D. Can we write it?
Yes, sure.
Yes, rest of the student, are you getting it? Are you
Yes, ma'am.
getting? Yes, Sazia, Safia, Farhan, are you
Yes.
getting it?
Yes, ma'am.
Okay, and hence we are done. Okay, this is how we'll be doing it. Is it clear, the proof? Is it clear to all of you? Have you noted it?
Yes, ma'am.
Okay, so then let's solve a question. Converse also we'll be discussing, but I don't want to discuss the theorem. Like you will end up getting confused. Let's let's do one question. Okay. Here question says that ABCD is a quadrilateral in which P, Q, R, S are midpoint of the sides AB, BC, CD and DA. AC is a diagonal. Part 1 is SR parallel to AC. That's what we have to prove. And SR is half of AC. Part 2 is PQ is equals to SR. Part 3 is PQRS is a parallelogram. Okay. P,
Yes, sir.
Q, R, S. Let's focus what the question says. This is first question from your book. Okay. Let's see what the question says. Here the question says that ABCD is a quadrilateral. Yeah, we can also say it's a quadrilateral in which P, Q, R, S are midpoint of the side. So P is the midpoint of AB. Q is the midpoint of BC. R is the midpoint of CD. And S is the midpoint of DA. These lines are given, these points are given in such a way so that P is the midpoint of AB. I'm not saying, read the question, PQRS are midpoints of ABBCCDDA. Okay, it's given in the question. Okay, and AC is the diagonal, which we can also see. Now what we have to show? We have to show that SR is parallel to AC. So if you will take this triangle, tell me, if you will take this triangle, I'm talking about this triangle. If you will focus on this triangle and you know that in this orange color triangle, S is the midpoint of AD and R is the midpoint of CD. Then can we say by midpoint theorem SR must be parallel to the third side? Yes or no?
Yes,
अभी
ma'am.
अभी मिड पॉइंट थ्योरम में अभी तो यही तो हमने सीखा है कि अगर एक ट्रायंगल में दो साइड्स के मिड पॉइंट को ज्वाइन जैसे ही करेंगे, वो जो लाइन सेगमेंट होगा वो तीसरे साइड के पैरेलल होगा. तो ये ट्रायंगल तो कुछ ऐसा ही दिख रहा है. See, now only we have done the discussion that in a triangle, if we are joining the midpoint of any two sides, that line segment will be parallel to the third side. And can you see in this orange color triangle, there is a midpoint of side AD, that is S, and midpoint of side CD, that is R, and we are going to join them. So this SR must be parallel to AC, yes or no?
Yes, ma'am.
Everyone getting it?
Yes, ma'am.
Rest of the student, Safia, Sazia,
Ma'am,
Irshad, yes?
ma'am, for the first one, can we say in
Yes, ma'am.
triangle DAC, R is midpoint of DC and S is midpoint of DA. So SR is parallel to AC and SR is equal to half of AC.
That's it. That's it. Exactly this is. Okay. In triangle DAC, S is midpoint of AD and R is midpoint of CD. Therefore, by midpoint theorem, by proper, or you can write the theorem, or directly we can write by midpoint theorem. Okay. By midpoint theorem, SR must be parallel to AC and SR is equals to half of AC. We are done. That is the job of the theorem, that it will make our work simpler, and you can see, can you see, it's so simple.
Yes, ma'am.
We are done. Now you want, you can copy it. Okay, this is the explanation. We are done. Now the next one is PQ is equals to SR. Okay,
Yes, ma'am.
so we will be doing the same thing. First, let me know, is it clear so far to everyone?
Yes, ma'am.
Is it clear so far? Sazia, Safia,
Yes, ma'am.
Irshad, Farhan.
Yes, ma'am. Clear.
Okay, now we have to show that PQ is equals to SR. So again we'll be saying, okay, again for part 2, we'll be saying in triangle ABC, again we'll be saying P is the midpoint of AB and Q is the midpoint of, okay, P is
DC.
midpoint of AB.
Ma'am, I have taken triangle BAC.
Yeah, that is good. Okay. Midpoint of AB and Q is the midpoint of BC. Therefore, PQ must be parallel. Okay. And Q is midpoint of BC. Therefore, PQ will be parallel to again the same AC, and also
Half
PQ
of
will
AC.
be equals to half of AC. Now you tell me, we are saying PQ is equals to half of AC and we have written SR is equals to half of AC. Okay, from equation 1 and equation 2, can we say that PQ and SR both are same? Yes or
Yes,
no?
ma'am.
Yes, sir.
Okay, so from 1 and 2, if
From one
both
to we
are
can.
half of AC, PQ is equals to AC. Wait, PQ is equals to SR. That's what we wanted to prove. Is it clear?
Yes, ma'am.
Irshad, is it clear?
Yes, ma'am. Clear.
Now the last one. It's a parallelogram. So let me. PQRS is a parallelogram. Just a second. So of course it's a parallelogram.
Yes,
Opposite
ma'am.
sides, this side SR is equals to PQ. Similarly, we'll be writing. Okay, directly let's write. Similarly, PS will also be equals to QR. Okay,
Can we
here
use SR is parallel to AC?
SR is parallel to,
AC.
yeah, we have written SR is parallel to AC, PQ is parallel to AC. So yeah, we can, here only we can do the comparison,
Okay.
that SR is parallel to PQ also. Okay, because SR is parallel to AC, PQ is parallel to AC. So both are parallel with each other. Yes or no?
Yes, ma'am.
Am I making sense to all of you?
Yes, ma'am.
Yes, ma'am.
Okay. If SR is parallel to PQ and SR is equals to PQ, therefore only in part 3 what we'll be writing. So this one you have to write in. we know that PQ is equals to SR, and also PQ is parallel to SR. Okay, from 1 and 2 you can write over here, from equation 1 and 2. Okay, therefore PQRS is a parallelogram. Only this much is okay to declare that it's a parallelogram, and we are done. See how useful the midpoint theorem is. Is it clear to all of you?
Yes, ma'am, it's clear to me.
Tejas, to you it's clear. Rest of the student, is it
Yes, ma'am.
clear? Clear.